Mathematics is a language. In order for the language to be universal, it needs a set of rules. That set of rules is called the order of operations. We use the order of operations anytime we want to simplify some sort of mathematical expression or an equation. Let's see here. The order of operations consists of following brackets first, then exponents, then you multiply or divide depending on the order, and then you add and subtract depending on the order at the very end. We're going to have a few examples of these so you'll see how that works. Before that, there's a few things to recall. We got the sign rules for multiplication, division, and double signs. Those consist of anytime you have the same sign within one of these becomes positive. If it's a different sign, two different signs, becomes negative. So let's look at a few examples of that. Say you were multiplying 2 times -3. So you're doubling a loss of 3. Doubling a loss of 3 gives you a loss of 6. You'll notice positive times negative gave you negative. Let's create that same statement and make it a division statement. So -6 divided by -3 should be 2. And if you look at the sign rules, negative divided by negative gives you positive. Double signs is when you have two signs right side by side. So here's an example. Say you had 4 minus -2. You had $4, but then you lost your debt of $2. Losing a debt is actually gaining, so that's like a plus. The next thing to recall is what an exponent is. So let's quickly review that here. If you had a to the power of n, so the exponent is n, and a would be called the base. That would mean that a would be multiplied by itself n times. Very important example to give you regarding to exponents would be when you have brackets mixed into exponents. So let's say you had -3 in a bracket squared. So in this case, the square right underneath the square is the bracket, meaning you're going to square the bracket. Bracket times bracket, -3 times -3 gives you, by the sign rule, +9. However, if you didn't have the bracket, careful here. The square is right underneath the square, you have 3, so the square is only applying to the 3. So the negative hangs out, and then you have 3 times 3, giving you -9. Another thing to consider is add the absolute value. The definition of absolute value is the distance from 0. Absolute value is signified by bars, and those bars under the order of operations fall under brackets. There's a few examples. So let's say you had -3 in an absolute value bracket bar. You'd have, how far is -3 from 0? 3 spaces. How far is 5 from 0? 5 spaces. They act like brackets, so if there's something inside, you would do that first. So absolute value of 2 minus 5 gives you absolute value of -3. And then you can, once it's one number, you can evaluate using the absolute value rule of how far is -3 from 0. It's 3 spaces. Another important example is if you have, say, a sign hanging out front of the absolute value. It's still, just like here, hanging out. It's not part of the absolute value question of how far are you from 0. So if you had negative absolute value of -3, that would be negative, and then absolute value of -3 was 3, so -3. Let's look at a few examples. This is probably the best way to really understand and learn the rules of the road in mathematics. Let's stick the BEDMAS up here so you remember. brackets, exponents, division, multiplication, addition, subtraction. And we work this way in this direction. So in number 1, we don't have any brackets, we don't have any exponents. We don't have any division, we have some multiplication. So we start with the multiplication bit, and that gives us 2 times 2, which is 4. We can rewrite everything else that was being done. That gives us 6. Because now we can do the addition after the multiplication has been complete. You can imagine if you just went left to right here, you would have gotten 2 plus 2, which is 4, times 2, which is 8, which is completely different. So following the order of operations will ensure that you're following what the person writing the equation meant. Let's try the next one. Next one's got a bracket, so we got to stick inside the bracket, and then within that bracket we start over and look for anything else. So in here we just have addition and subtraction, which can be done together. So everything is rewritten except for the part being done, and then you can do the part that's being done. So you have negative 5 plus 2, a loss of 5, a gain of 2 gives us negative 3. Continuing, now you can look at it, the bracket is finished, it's just one number, that's it. There's a hidden little symbol here that you should be aware of. Anytime you have a bracket and a number in front, there's always a little hidden times sign there, but you never really see it. It's just kind of assumed. Mathematicians like to take shortcuts, and they make this sort of playing field where that's just assumed. So anytime you see a little space like that, bracket and a number, no other symbol there, it's a multiplication by default. So let's try that. We got multiplication. We cannot do this subtraction first. Very important. That would give us something completely different, and it would not be following what the writer intended you to follow. So we have to rewrite the 7, but now we've got the negative 3 times the negative 3. Using our sign rules, that gives us negative times negative, giving us positive, and 3 times 3, 9. Giving us 7 plus 9, which is 16. We got some more examples. So just make sure, if you would like to, you can pause the video at any time, try the example, and then replay and check out if you did it right. So in this one, we've got this big bracket here. It's square, but really it didn't have to be square. It's just for visual appeal. So this bracket could have been a regular bracket. It's just signifying that it's the outside bracket. So let's rewrite that bit. We're going to look inside first. And inside, we have to start over. We look for, are there any other brackets we need to complete inside? Yes, we have this negative 3, which is not really anything we have to complete, so we just rewrite it. But this here, 4 minus 9, has to be completed. 4 minus 9 gives us negative 5, which is then squared. So in the next step, we can rewrite everything except for what we're doing. And what we're doing now is we have completed the brackets, but now we're on the exponents. So remember, the bracket squared, the bracket negative 3 squared, is really squaring the negative 3 times the negative 3, giving you positive 9. So there's 9. The minus is rewritten. Now the negative 5 is squared similarly, giving us negative 5 times negative 5, which is 25. Now we take a look, we got negative, and really when there's no number here, it actually means a little negative 1 times the rest of this. That's another default. So if there's no number in front of the bracket, it actually means times 1, because multiplying by 1 doesn't do anything, so they don't usually write it. 9 minus 25 is negative 16. That's completing the bracket. So now we just have to multiply negative 1 times negative 16, which is positive 16. Next, absolute value. Absolute value of negative 3 means the distance of negative 3 from 0, which is 3 spaces. Done. However, when the absolute value has something in it, you have to treat it like a bracket. So inside here, you have 2 minus 5. 2 minus 5 is negative 3. Everything else stays. Again, there's a little times sign here that is hidden, and you can put it in for yourself if you'd like. So now let's actually complete the absolute value. The bracket has to be released. The absolute value has to be released in order to do anything further. So the absolute value of negative 3, as in question number 4, is only 3. So rewrite everything else. You've got negative 4 times 3 giving you negative 12. Here's another long one. Pause, try it out, and then come back and see if you get it. Alright, so big bracket, big absolute value here that we have to complete first. The subtraction gets done at the very end. Do not do it right away. Just keep rewriting it until the very end. Let's work inside this bracket here. So inside this bracket, there are no other brackets to complete, but there are exponents to complete. So rewrite everything except for this part, and what we're doing is negative 2 in a bracket squared, meaning negative 2 times negative 2, giving us 4. Alright, let's continue. So 11 minus 2 times this whole thing. Let's simplify this. We only have a multiplication and division, so when it's down to multiplication division, you can do it in order left to right. Doesn't matter which one you do first. 8 times negative 2 is negative 16, and rewrite the divide by 4. That gives you negative 16 divided by 4. That gives you negative 4. The absolute value is still there. Once it's down to one number, you can evaluate the absolute value. So 11 minus 2, remember there's a hidden times sign there when there's nothing written between them. And so this is really negative 2 times, and what's the absolute value of negative 4? That's the distance of negative 4 to 0, which is 4, giving you 11 minus 2 times 4, which is 8. 11 minus 8 is 3. Here's another example. This one's a little bigger. Let's try it out. One note here is when you have a bar in the middle, that signifies you basically have brackets on the top and the bottom, which really could be written the top divided by the bottom if you really want to, or you can just keep it as top and bottom visually. So really just do the top and bottom separately and follow BEDMAS within each one. So within the top, we've got negative 3 squared. It doesn't have a bracket this time, so that means negative 3 squared is negative 3 times 3, giving us negative 9. So that's a negative 9 minus, we're still on exponents. Let's finish these exponents. Negative 2 cubed is really, let's do that on the side here. Negative 2 times negative 2 times negative 2, giving us negative 8. So that's a negative 8 there. So now we have a double sign, which is negative 9 plus 8. A loss of 9, a gain of 8 gives us a loss of 1 still. Let's work with the bottom. The bottom's got an absolute value that we have to complete first because it's like a bracket. So you have 4 minus 3 gets rewritten. Never do that beginning subtraction. Don't fall for it. Everyone does. So absolute value stays. 4 minus 5 is negative 1. So really this is just a 4 minus 3 with a little times sign there. Remember, that's a default. Times the absolute value of negative 1. So how far is negative 1 from 0? It's 1 space. So really that's just 4 minus 3 times 1, which is 3. So that's still the same. 4 minus 3 is 1. So this whole thing boils down to negative 1 divided by 1, which is negative 1. Really shows you the beauty of mathematics, of this complicated beast becoming this simple number.